Okay. Okay. Thank you everyone for coming and for listening. For attending. So I'm here to talk about how to increase visibility using perf IPFIX sampling in OBS and OVN. I guess IPFIX has been present in OBS for a long time, but maybe it's not a feature that has been given much of attention recently. And I think that it can be used to greatly increase the visibility on complex OBS and OVN clusters. So I'm going to first introduce what is IPFIX, well, not much of what is IPFIX, but how IPFIX works in OBS, the different modes in which it is supported, and then the potential of using perf IPFIX sampling using OVN, and its potential in increasing visibility. Last, I will present a couple of examples of how this can be achieved in a demo. So I'm not going to introduce what IPFIX is. I assume that most of the audience here know what IPFIX and Netflow is. It's basically not only a protocol, but an information model, architecture, and much more. I'm just going to introduce some terminology that is going to be useful in the presentation. So essentially, IPFIX is based on an exporter sending traffic flow information to a collector. Now, flow here is not OpenFlow or datapath flow is something else. It's a collection of it's basically information about a packet or a set of packets that share some common fields. You can think about it as a pipe tuple, essentially. The information, when it reaches the collector, it has to be interpreted. And in order to do that, the exporter has to send things called templates. These templates contain a set of fields. It basically describes what kind of packets, what kind of information we can send. And so each template kind of defines a set of field IDs, lengths, so on, which are called entities. There are many standardized entities. When the exporter sends this information to the collector can now interpret the information that it's receiving and parse it and whatnot. So again, I don't want to go into sorry. So I don't want to go into a lot of detail of IPFIX and the protocol, and nor all the entities, but I do want to go over two of them because they are going to be important for OBS implementation. So IPFIX architecture can get complex, and in IPFIX there's a thing called observation domain. And an exporter can have many observation domains, and each observation domain can have many observation points. And these basically give context to the collector or to the person or machine that is interpreting the information, the network information. So these two fields can be present in IPFIX traffic, and there are these two IDs called observation domain ID and observation point ID, which are defined, and they are 32-bit long, and these two fields can be used to, again, give some context on the IPFIX, on the traffic information. So let's jump into how OVS supports IPFIX. There are essentially two modes in which IPFIX is supported. One of the modes is called per breach sampling, and the other one is per flow sampling. I'm going to go into a little bit of detail into how these two modes work. They share some common infrastructure inside OVS. Essentially, the core components of this shared infrastructure are the template definition. So basically, there's a template for each combination of L2, L3, L4 headers, or protocols, sorry, more or less. And there is a configurable flow cache. So the configurable flow cache can be used to improve performance and, basically keep the flow information inside OVS and just increase the number of packets that are seen within that flow. It does increase the latency until you see that flow appear in your collector, but it reduces the traffic that goes back and forth. So it is definitely worth considering if we're using IPFIX on production setups. So let's start with OVS per breach mode. This is a command line that you can use to configure per breach mode in OVS. So let's try to break it down. So first thing is, it is associated with a breach. Its name suggests. So you are associated with a specific OVS breach. You fix an observation domain and observation point ID. You just set it in the command line or in the OVS DB. It is you can configure egress or ingress sampling. And you have a global sampling rate. So in this one-liner, we have specified, sampling equals 400. By the way, it means 1 on every 400 packets will be sampled. So OVS will sample those packets, put those observation domain and observation point IDs, and send it to the target IPFIX collector. So this is essentially it. So it is simple. It is just that. That command line is enough. And very quickly, you know what traffic is flowing through the through your OVS instance. However, it is not very fine-grained. As we saw, the sample rate is global, and so are the observation domain and observation point IDs. So we are kind of just sampling a bridge as if it was just that, a normal bridge. But VRIN, for instance, in OVN, is not just a bridge. So this setup of this mode is not allowing us to observe and distinguish between all the virtual datapaths that OVN can install. And so we are kind of lacking some granularity here. So this is more or less a quick overview of the per breach sampling. Let's go to the per flow sampling. Per flow sampling is configured using that command. And if we break it down, we see that we still have the common part. So cache size, maximum number of flows, we still have that. So that's great. Of course, we have an IPFIX target. However, we now see something called a flow sample collector set. So there is an intermediate table in the OVS database, and we use this intermediate table to basically link the breach with the flow collector flow collection instance. Let's call it that way. and it has an ID. It is important to keep that in mind because we will go back to this ID. The flow sample collector set ID is something that we must keep in mind. Now, that command is not the only thing that we need in order to have this working. This configures OBS to send packets to the IPFIX target, send IPFIX information to the IPFIX target. But what flows are sent is determined by an OpenFlow flow. So if we add this flow, for instance, we could make it work. So this, we are using the sample action, as you can see, and we use the collector set ID inside the sample action to refer to the collector flow sample collector set line in the OBS DB. So that is what we have to correlate, and we have to do that. Have to be careful to do that properly, or else it will not work. However, what we do have here is that each flow has its own observation domain and observation point IDs and probability and sampling rate. So this, and of course, it is OpenFlow, so we can specify an exact match of the packet that we want to sample. So if we analyze the pros and cons of this setup, it is much more fine-grained. It can express beautiful datapaths because we have these observation domain and observation point IDs associated with each of the flows. We could, for instance, express virtual datapaths defined by OVN using this mode. However, it is much more complex, and it's not an OBS only thing. We need OpenFlow. We need the OpenFlow controller to play along and configure all these flows, and add these sample actions to all these flows if we want to sample something. However, this is where OVN can help, and this is essentially what I want to talk about: how OVN can help bringing per flow sampling to production clusters. So OVN support of IPFIX. This is the sample action, OVN sample action, not to be confused with the OpenFlow sample action that we saw before. So the OVN sample action is being introduced in OVN. The patches are in the list, and it essentially has some parameters. We can define the probability, 32-bit field. We can select. We need to specify the collector set ID, which, as I already mentioned, has to match the one that we configure in OBS for this thing to work. And we can configure the observation domain and observation point IDs. Now, the observation domain ID, it's only 8-bit long, and the idea is that the observation domain would represent the OVN sampling application. So in order to support several different sampling applications within OVN, we can specify this observation domain, 8-bit long observation domain, that we combine with the datapath key to form the final observation domain ID that will be inside the IPFIX packet. And finally, we can specify the observation point, which can be a 32-bit observation point ID that you can just put there, or it supports the cookie macro, which expands automatically to the logical flows, the first 32 bits of the logical flow UUID. So it can be used to track, to basically correlate back what logical flow introduced this sample action. The consumer, I'm going to go quickly. Basically, the consumer of this of the resultant IPFIX traffic can be any IPFIX collector, as long as it supports the observation point and observation domain IDs. Many of them supported, for instance, NFDOM version greater than 1.7 supports it, and if you it has these ODID, OPID field names that if you specify them, it will print the observation domain and observation point IDs, with which you can then correlate back to your OVN information. So, two applications of this. First application is drop sampling. It's basically trying to answer these questions that we've all had. Is OVN dropping my packet, and if so, why? When we ask ourselves this question in a running cluster, it's typically rather complicated. This mode that is being introduced in OVN essentially configures a collector set. It configures the collector set ID that has to be, again, that has to match the one configured in OBS, and it specifies domain ID, this OVN sampling application. If we put a simple number like 1, that will make OVN add a sample action to every single drop that it explicitly makes in the data path. I have a demo of this. So let me see if I can quickly stop sharing. Share this. I hope you see something here. So I have a Kubernetes cluster, a kind cluster, Kubernetes cluster in my own laptop, and I have a namespace with a couple of clients and service. And what I'm going to run now is a program called OVS Flowman. So OVS Flowman is basically an IPFIX collector that brings up terminal user interface and it prints the flows in a table. But it's essentially just an IPFIX collector that enriches the information using OVN. I'm going to deploy it on one of my worker nodes and see what it gives us. As soon as I deploy it, I see packets, which means as soon as I deploy this, I see that OVN is dropping some packets. So if I scroll to the right of this table, I not only see the source and destination MAC address, protocol, source and destination IPv6 in this case addresses. I also see the logical flow UUID, the match, logical flow pipe, the pipeline. So in this case, we have an ingress IP routing drop in a logical router called GR OVN worker 2. And we have all the information of the logical flow that has dropped this packet. So there's clearly something OVN is not expecting, that IPv6, and it's not knowing how to route it properly. And also we have another drop here caused by ARP or neighbor discovery, which is also not expected. And we also get the packets and bytes that were dropped. If I were to generate some traffic that I know is going to be dropped, let me see. And I'm going to, what I have here is, as I said, a Kubernetes cluster. So I'm going to jump into one of the pods that I know that cannot curl a service, and I tell you why I know it in a while. So I have basically a pod that is not being able to access a cluster, a service, and from the, let me just deploy this again. And I hope to be able to identify why. And immediately I see that there is IPv4 traffic here. Each new sample is being added to the table. So because it has a different source port, so let me remove the source port from here. So it will combine all the different source ports. And clearly we see that there is TCP traffic being dropped in the port 8080, and the reason is an ingress logical in the out logical switch out ACL in egress. Okay. We see it right there. So that is exactly that. From then on, we can now inspect OVN. Why is that flow there? So let me just go back to the presentation. And briefly talk about another example. The other application that is being proposed, this is also an RFC that is in the list, is called ACL Sampling. So basically the question it tries to answer is, are my ACLs working well configured? Are they dropping traffic? And the implementation is basically creating a new sample table and linking the ACL, each ACL to this sample row. But this is just, I'm not going to go into details because that's an RFC and this might change. I do want to try to give my opinion on why this ACL sampling would be beneficial and how it compares with another feature called ACL logging, which is already present. ACL sampling has caching, and that caching is done in OVS, but the external collector is an external IPFIX collector, and it's not OVN. Not the OVN controller, which is good if we have lots of logs coming up from the data. ACL sampling, with ACL sampling, we have information of the packet that was dropped or that matched that specific ACL. So we have much more information and in order to debug. And the protocol is standard. It's not just a text log. And we could have sampling, and if that sampling can have different value, different probability, basically, for each ACL. So if we're interested in some of them, we can basically increase the sampling rate on that one, and that's it. And I have a demo for this, but I'm running out of time. So yeah, I think we can stop now and yeah, give time so to some questions if you have some.
All right, let's thank our speaker. Do we have any questions in the room? I'm going to give a few seconds for the remote side to let us know if they have any questions.
There's no questions in the remote.
There's none in the remote? Okay. Oh, okay. So we have a question in the room.
So, thinking about the previous presentation to hardware offload, is there any impact of enabling sampling when we have hardware offload?
Can you hear you, Dimitri? I could not hear you.
Oh, sorry.
Yeah, the question, well, I can repeat the question. Yeah. The question was, what is the impact of sampling in hardware offload? Which is a very good question. So currently, sample action is not supported. It's not supported in hardware offloading. So that will make the flow not be offloaded, which I guess it's it makes it complicated for applications that are very performance centric. Like if we want to sample all ACLs, all ACL traffic, including traffic that we are accepting, that would probably be a problem for hardware uploading setups. For the debug, for the drop sampling mode, well, it depends. I guess if traffic is being dropped and you don't want it to be dropped and you want to debug it, probably you can temporarily pay the cost of not offloading it just to give you visibility on it. As soon as you remove the flow, remove the sample action from the flow, it should get offloaded back. So, yeah, current state is not uploadable.
Hey, Adrian. We have one question from the virtual attendee. James Troop has asked, the drop sampling looks very cool, but I'm worried about it being global and usage in large clouds. Would it be possible to limit it down to, for example, a hypervisor or VM in the future?
Yeah, so absolutely. Should I repeat the question or is that mic? Okay. So the option in OVN is global, but you need to specifically add a role in the OBS flow collector set ID in order for that hypervisor to start sampling. So even if the option in the OVN is global, you can enable it just on a specific hypervisor. Actually, my demo was only sampling one specific hypervisor.
Okay, thank you. We do have one more question from the virtual audience. So one question, this is from Daniel Alvarez. One question that comes up in OpenStack sometimes is packet counters for billing purposes, available with ML2 OVS and IP tables, but not with OVN. Would this potentially allow a way in OVN to know the amount of egress and ingress traffic for a particular tenant? So like logical switch to logical router to local net logical switch.
Yes. IPFIX in OBS does keep track of bytes and packets that match that specific flow. And so if we enable it in ACLs, then sure, we have accounting for each of the ACLs. Yeah. Thank you. It's a good use case, actually.
One other question, like, can we, toggle the sampling on and off at runtime so that, to also handle like hardware offload issues, we can enable sampling for a certain duration so that it doesn't impact. So the patches support that?
Yes, they, you can enable and disable sampling, and since when you disable sampling,